Hello, my name is Jennifer Lewis, and I am a senior solutions engineer at Couchbase. I'm going to do part one of a 5-part series based on the 5 high availability features of Couchbase. So today we'll just cover the first one, but so you know which ones they are. Number one is write failures and durability, which is making sure that your data is committed before receiving a success or fail. And then the second one is about how we handle node failures and failover so that your application can continue to work with and get to all of the data within your cluster, whether it's a planned node outage or unplanned. The third is cloud availability or rack zone availability. So making sure that your cluster is fully operational for your applications in the event that either one of those happens. And fourth is around losing an entire cluster. How can we provide high availability to all of your clients if that should happen, whether it's a data center failure or a cloud region failure of some kind. And then fifth, what to do in the event of not maybe losing a cluster, but realizing that something has happened internally within your applications to corrupt your data, make it, inaccurate or unusable for your use cases. How do we support you with that type of scenario? So today we're just going to talk about write failures and durability. So durability ensures the greatest likelihood of data writes unexpected anomalies, such as, say, a node outage. So writes in Couchbase from the SDK or some other client are written to a single node. That's because it knows where every single document is. And from there, Couchbase Server will take care of sending that mutation to any configured replicas. We support between 1 and 3 replicas of each data set. By default, all writes are asynchronous, but the level of durability can be set to ensure that replication and/or persistence to disk before the write is committed. And that's what we're going to talk about as the different levels of managing that. So the writes to your bucket or AKA database can optionally be assigned durability requirements, which instruct the Couchbase server to update the specified document on multiple nodes in memory or in disk locations across the cluster. So before it's actually considered if that write was successful, it will check these durability level that you tell it before it sends an ACK back to the calling client. The greater the number of memory and or disk locations specified in your requirement, the greater the level of durability. So durability requirements can be set at the client level, assigned to a bucket or both. And both Couchbase and ephemeral buckets are supported. However, ephemeral buckets, because they don't involve writing data to disk, do not support the higher levels of durability that do require confirmation of your write being put on disk. So once that has been, the write itself has been committed and specified by the requirement, Couchbase server notifies the client of success. And if it's not possible, then Couchbase server will notify the calling client that it was a failure and the data retains its former value throughout the cluster. And this form of write is referred to as a durable or synchronous write, since the default is asynchronous. So Couchbase supports the durability for up to 2 replica data sets. So even though I said we support you to have up to 3 replica sets of a single bucket, if you so choose, durability is only supported up to 2 replicas. So as I've already kind of stated, none is the default level of durability for Couchbase, and that's just that regular asynchronous write. So this could be appropriate when writing, say, a data set whose loss would produce only maybe a minor inconvenience. So for example, a single instance of sensor data out of tens of thousands of instances that are being written continuously. it may not matter that you know it's been persisted to multiple levels before you want a success back, because each level requires a little bit more time on the microsecond, millisecond level. So it's something to consider to only use when your use case really requires it. So the next level is called majority. And for example, if you had one replica data set, the mutation would be required to be replicated to, or that is held in memory, allocated to the bucket on a majority of the data service nodes. So if you had 3 data nodes, it would be required to be written to both the active and the replica set, which would hit the 2 nodes before it would give you that ACK back to the calling client. The next level is called majority and persistent active. In this case, the mutation must be replicated to a majority of the data service nodes, and additionally, it must also be persisted, that's written and synchronized to disk on the node hosting the active V bucket for that data. This is, of course, because you're interacting with the disk data copy, only supported on Couchbase buckets. Persist to majority is the highest level, and this mutation must be replicated to a majority of the data service nodes, and additionally, it must also be persisted, that is written and synchronized to disk on the majority of data service nodes. So if you had 3, that would be 2. And once again, that is only supported on Couchbase buckets only. So I hope this has given you a good sense of your options when it comes to durability. And if you want to learn more about that, you can check out our documentation page on durability. Do understand that the durability in the SDKs is supported on all the SDKs. And there is a great blog posting on how you can do the performance testing and actually see and understand how your durability level that you're using may affect your round trip, mutation transaction time. So hopefully this has been helpful. I'm Jen Lewis. I will be posting part 2, which is on node and node failure, shortly.